Okay, so let's finish up our stuff on memory. Let's talk about forgetting, constructing, and improving, including false memory. So forgetting stuff obviously can be frustrating, right? Nobody likes to forget to lock their doors or get the answer to an exam question, whatever it might be, right? But also keep in mind that forgetting is adaptive, and it is actually quite important. So the reason forgetting is adaptive and the reason it's actually important is that it allows us to focus on important things rather than unimportant things. So, for example, if you could remember everything that ever happened to you, it would actually make things quite hard on you in some ways. The reason is that you'd have trouble focusing on the more important aspects, right? So, for example, again, if you took an exam, right, and you, in response to a question, remembered not just the answer you wanted to remember, the answer to that question, but remembered, say, every answer to every question that's ever appeared on an exam. Well, that would be pretty tough, right? You'd have so much information to sift through that you couldn't, or would at least have a very difficult time getting to the answer you actually need, the answer to that particular question, right? So if I ask you, what does the hippocampus do? And immediately you're flooded with not just stuff about the hippocampus, but basically everything about the human brain. It's really just a distraction, right? And this seems to be the case with people who have super memories, right? They can't really focus on the important memories because they remember everything, right? What's also interesting is that people who do have what seem to be super memories also actually have trouble with kind of inference, what we call inference abilities. So being able to kind of take away the most important part of something and kind of fill in the rest of it. Okay, that's just a little side note. So there's a lot of different explanations for forgetting, or at least there have been, but let's focus on just three here. So we talked about kind of the good old model of memory, where you have different stages: sensory, short term, and long term. Well, remember that short term only transfers to long term if you engage in some sort of attempt, right? You have to either keep repeating it or you have to process it on a more meaningful level, right? So with that in mind, you can probably imagine that there's a lot of things you've encountered before quite a few times, but that never really got transferred to long-term memory. This is what we mean by an encoding failure, right? You might encounter something and it enters, you do attend to it very briefly, so it does enter your short-term memory, but it never gets to your long-term memory. You never process it further enough to the point where it actually sticks, right? So there's lots of classic examples of this. One is if you show people, they did a study where you show people variations of the Apple logo, which everyone's seen the Apple logo probably dozens of times, right? Seems like something you could quite easily remember. When you present people with quite a bunch of similar Apple-looking logos, they actually can't pick out what exactly is the right one. So this kind of illustrates that even though something might enter your short-term memory quite a few times, it might never transfer to long-term memory. This is what we mean by encoding failure. Another example is a US penny. So you've probably seen lots of pennies, but it's actually quite hard to remember it in exact detail. There's another explanation. So just as an example of that, which is actually the correct penny? I don't do I have the answer? No, I don't have the answer. So you can look that up. But right, penny is probably something we've seen many times, although we do pay with cards and stuff more now. But they did this experiment actually a long time ago in like this, or in the 70s, where people paid in cash, and like not that many people could actually pick the right penny, even though they've been exposed to it so many times. Okay. Another one is storage decay. So going back to the 1800s, Ebbinghaus, he did a lot of experiments looking on the decay of memory. So if you learn something and you learn it, keep studying it until you can recall it perfectly right away, how does your forgetting act as a function of time, right? So how much of that 100%, if you can remember 100% immediately after studying it, how much can you remember after 19 minutes, 63 minutes, 1 day, 2 days, 6 days, 31 days? And you can actually plot, or actually he did plot what that looks like here. One thing you might notice is that it's really sharp right after you learn it, right after the immediate decay. So leading up to about 1 day, it's a really steep decline in how much you'll remember. After that, it kind of flattens out. So it's not a perfect linear relationship, right? It doesn't always decline in a consistent fashion. It's really sharp at first. You forget things really quickly, and then it kind of tapers off, right? Of course, the other one, and by the way, so storage decay is just kind of the theory that with just neutral passage of time, things kind of on a neural level are basically evaporate. They kind of stop working, they fade away, and that's why we forget. This is actually not really true, and when memory was really starting to develop and kind of be better understood, we found that it has more to do with interference, not so much passive decay, but you cover that in other courses. The other reason we forget is, of course, retrieval failure, right? So classic example of this is the tip of the tongue state, right? When you feel like you can't recall a word, but you know it, right? You feel like I can't get it this second, but I'm going to recall it soon. We've all had that experience before. This is known as a retrieval failure. Or even if you just don't necessarily feel like you're about to recall it, but you just feel like I can't think of the answer, but I know it. I know it's in my memory. That's called the feeling of knowing. These are examples of retrieval failure. So you have something in memory, but for whatever reason, you can't access it. Right? It's definitely in there. You know you learned it, but you can't access it. That's retrieval failure. Interference has a lot to do with retrieval failure and just memory loss in general. So there's two types, proactive interference and retroactive interference. So proactive interference is forward acting. By that we mean past knowledge interferes with your ability to learn something new, right? Hence forward acting. Retroactive interference is when learning something new makes it hard to remember something or retrieve something old, right? So, for example, with proactive interference, let's say you had previously studied French and then you try to learn Spanish. Well, French and Spanish are actually pretty similar. So if having learned French previously makes it harder to learn Spanish, this is proactive interference, right? In contrast, if you learned French first and then studied Spanish, and studying Spanish made it hard to remember French, this would be retroactive interference, right? Interfering with what you already know. A new thing is interfering with what you already know. Okay. All right. So with all this forgetting that we do, right? We obviously can't remember everything. Not everything. In fact, the majority of things don't enter long-term memory. Majority of things don't even enter short-term memory or working memory. You can imagine where our memories are not always precise, right? And the general finding is that we tend to remember kind of the most important things, but not necessarily all the details. of an event. So for example, with pennies, I mean, I'm sure you could tell the difference between a penny and a $20 bill, or a nickel, or a dime, or whatever, right? But the specific details, well, that's a different story. Remembering exactly what the penny looks like, rather than just the general shape, the color, who's on, kind of what the person on it looks like. That stuff's easier, but the details are a lot harder. So with that in mind, this can lead to a lot of different false memories, okay? Another thing is that there's a process known as reconsolidation. So every time we replay a memory, we often replace the original memory with a slightly modified version, okay? So, for example, let's say you were, well, this happens a lot with flashbulb memories. If you, first time it happened, you remembered, oh, I was at school when there was when the 9/11 attacks happened, right? Well, the next time you relive that memory, when you kind of try to replay it, try to remember it, you might actually be adding details to it that never happened, or you might be modifying the memory in some way. So you might just kind of fabricate the detail that, oh yeah, I was also feeling kind of sick that day, right? And each time you do this, each time you replay a memory in your head, you reconsolidate it, you reactivate the memory, but you can also modify it, right? So if I'm reliving a memory over and over again, each time it's susceptible to me adding something that never happened or modifying something, a lot of which might not be accurate. So with all that in mind, let's look at some experiments on false memory, some cool stuff. Classic one is known as the misinformation effect. So what you do is, forget about the color of the light for now, is you show people a car accident, right? So two cars in a car accident. And later on, you ask them one of two questions, depending on the condition. In one condition, you ask them, was there any glass when the cars hit each other? In the other condition, you ask them, was there any glass when the cars smashed into each other? Okay. What you find is that that simple change in word, just that one word or two words, hit or smashed into each other, actually changes people's memory for it. So when you say hit, when the cars hit each other, people are less likely to say that there was broken glass. When you say the cars smashed into each other, they're more likely to say that there was broken glass. By the way, there was no broken glass at all, right? So you're showing them the same video, but you're just changing how you phrase the question, hit versus smashed. And there's actually no glass. But people, when you say smashed, are more likely to think that there was broken glass than if you say hit. Why do you think that might be? Well, the reason is that people will reconstruct an event. So we just talked about reconsolidation, how when you replay an event, you can add details, right, that never actually happened. Also keep in mind that people tend to remember the overall meaning, kind of the important parts of a situation, like with the penny, not necessarily all the small details. So they probably don't remember small details like whether there was glass or not. To overcome this, what we have to do is we have to reconstruct the event, right? We have to kind of, well, we remember the, the most important parts, like there was a car accident, maybe something like the color of the cars, the time of day, but we don't remember all the details. So we have to fill those details in based on what information we have. So when someone says smashed, this is going to imply that there was a more violent collision. When someone says hit, it implies a less violent collision, right? Smashed sounds worse than hit, right? So we actually use that and we don't even realize that we are using it. But without even realizing it, we will often use that as a cue to reconstruct memory. So because smashed implies a more violent collision, when we're constructing the event based on what limited memory we have, we're more likely to guess that there was glass. Again, smashed implies it was more violent. Pretty cool. Another way you can do this is by basically asking questions. Or you can do this a few different ways. So if you also ask, say, how fast were the cars going when they hit versus how fast were the cars going when they smashed, you also get very different speed estimates, because again, we're reconstructing an event based on kind of the limited information we have and also what we're given at the time. So we use kind of the phrasing of question to make our best guess, right? Another thing you can do with misinformation is ask people questions about things that never happened. So, for example, if you say this happened at an intersection with stop signs as opposed to traffic lights, right? If you ask people, was it a yellow light or a red light or something like that, when the accident happened, they'll actually create a false memory for there having been a traffic light. So if you say, do you remember what the color of the light was, the traffic light, they'll actually create a false memory for a traffic light, even when there was no traffic light and you have stop signs instead. So that's another way you can do misinformation. And there's lots, and you can kind of imagine how this would manifest in something like an eyewitness situation, right? Asking what we call leading questions that kind of imply something happened, it can really change how a person will respond, right? Okay. Another thing is source amnesia. So this is kind of a big basis of a lot of false memories, source amnesia. And this is the inability to remember where, when, or how previous information was acquired, right? So for example, let's say that let's say you can't remember whether you told a joke or whether someone else told you a joke. I don't know if this has been empirically demonstrated, but I definitely think it happens. What happens is that you might end up telling the same joke to someone who told it to you, right? So say your friend tells you a funny joke, you think it's funny. Sometime later, who knows how long, you forget basically the source of that information, but you still remember the joke. So you remember the funny joke, but you don't remember who told it to you. Later on, you actually end up telling it to the same friend who told it to you, because you've forgotten the source of where you heard the first of the joke, right? There might be reason to that, such that the friend kind of cues you of the joke, even though you can't remember the source, but that's not important. Bottom line is, failing to remember the source of information can create a lot of false memories, particularly when you go into imagined versus real things, right? So for example, let's say that you were supposed to pay a certain bill a few months ago, right? Well, you probably thought about doing it a couple times, right? Maybe you never actually did it. So you just thought about paying the bill, but you never actually did it. Well, what might happen with time is that you might forget the source. You have this memory of paying the bill, right? But the trouble is that you can no longer, with time, distinguish the source of, did I do that or did I just think about doing that, right? Hence, you can get a false memory. You can think, oh, actually, I did pay the bill, when really you're just misremembering the source of, I only thought about paying the bill, right? Another example is, say, taking pills. Maybe you take a pill in the morning and you can't remember, did I take it yesterday or did I take it today? Right? You can end up taking it twice or not taking it. Pretty bad, right? Deja vu is actually something that we do a lot of in my lab. Deja vu is the feeling, it's a feeling of familiarity, but without source memory, right? So something, you might go to a new area, like an airport you've never been to before, and you feel like, wow, this feels real familiar, but you can't figure out why. right? It kind of feels oddly familiar because you can't remember the source of, oh yeah, I was in a different airport that looked just like this one. Okay. So I'm going to show you a series of words, and I want you to try to remember them. Okay. Actually, do this one, so get some pen and paper ready. Okay, ready? Okay, come backwards from 3, by 3 from 546. Okay, write down all the words you can remember. Just pause the video and resume it when you're done. Okay. Did you see glass? Did you see window? Well, let's go back. Let's check the glass and window were actually there. Glass was there. How about window? No, it was not. Window was not actually there. This is known as the Diess-Roediger-McDermott paradigm. And window is an example of what we call a critical lure. So what you may have noticed is, and even if you notice this, it usually doesn't matter, you still do it anyways. All these things are related to window. So door, glass, pane, shade, ledge, sill, house, open, curtain, frame, view, sash, screen, shutter, related to window, right? A lot of people, actually a pretty high majority of people, will report that they studied or write down the word window. But like I said, window never actually appeared. So this gets back to the idea of how we tend to encode the overall meaning of a situation, right? We're kind of remembering, encoding, maybe even implicitly, that all these things are relating to window. And we make the inference, because we can only remember the overall meaning of a list, not necessarily all the individual characteristics or features, we falsely fill in the word window. We make kind of an assumption, a construction of the word window. Again, window never actually appeared. It's just an inference made on the overall meaning of the list. So this is another classic false memory experiment. And people do so really confidently. They're certain they saw the word window. It's pretty cool because, again, we rely on the overall meaning and we have trouble remembering the specifics. We just make inferences about the specifics. Not always, but often. Okay, so a few last things before we wrap up. When it comes to improving memory, type of rehearsal is important. So remember that maintenance rehearsal is a lot less useful than elaborative rehearsal. So repeating a word over and over in your mind or a concept, not a good way to study, right? Rereading your notes, not a good way to study. The best way to study is to elaborate on something, right? Draw connections to other things, you know, anything that's going to let you elaborate on it. Connect it to other things, come up with a distinct story, think about it in terms of its meaning, right? Another big thing is that distributed practice is better than mass practice. Right? Always. So if you had the option of studying 1 hour on 1 hour each on 2 separate days versus 2 hours on one day, a lot of people end up doing a 1 2-hour session. And this is definitely not for the best. It's way better to have 2 1-hour sessions than 1 2-hour session. Right? That's what we mean by distributed practice. So space out your studying rather than massing it all together. Actually, I think a lot of you wrote about this in your mini writing about design and experiment. You said, is just spacing out your studying better than massing your studying? And yes, it definitely is. But one important thing there is that it's not an issue of overall time. So it's not that when I tell you that you should distribute your practice, I'm not saying you should study more, although that's always good. I'm saying you should study more frequently. So like I said, 2 1-hour sessions is not more time overall than 1 2-hour session. I'm just saying break it up a bit. Okay. Remember to use retrieval cues. So if you can think of something that's going to remind you of the thing in question, right? Any sort of trick, any sort of reminder is going to help. Try to match study and testing conditions, although there are limitations on that. And lastly, one thing I talked about briefly is the testing effect. So remember, a great way to study is to take practice tests, way better than rereading your notes. Okay? We do a whole unit on the testing effect in my lab course, but for now, just trust me on that. Okay. So a few summary points. Remember that forgetting is adaptive. It serves an important purpose. Forgetting can occur through encoding failure, storage decay, although that's somewhat questionable, retrieval failures. We may falsely construct memories and believe them to be true. Often it is the source of a memory that is the hardest to remember. So where you learn something, who you learned it from, is more easily forgotten than the information itself, right? A lot of memory research is dedicated to learning about effective techniques for improving memory. Okay, see you next time.